The other thing I wanted to say before I start, just to frame where I'm coming from with this a little, is my background's more in philosophy of neuroscience and cognitive science, relatively new to metaphysics. What I found is that there are a few accounts coming out of neuroscience and complex system science in the last few years, arguing for new forms of causal emergence based on information-theoretic constructs. And I was curious about what these are really demonstrating. So when we look at these with a more kind of metaphysical eye, what are they really managing to show? So that's what I've been working on. And then I've come to think maybe that's the wrong way to approach it. So as this is a methodology workshop, at the end, I'll try and say a little more about how we should think about what the metaphysics is of scientists, rather than forcing our preconceived metaphysics on them, perhaps. So let's see. Cool. So I'm going to very briefly say a little about the metaphysics of causal emergence. There's a lot I could say, and I won't say too much there, just to give us some background. Then I'll introduce these three different information-theoretic measures of causal emergence, and I'm going to try and give you more of just a general sense of what they're arguing for, and not really the formal details of that, so it shouldn't matter too much. If any of them are in the audience, which they might be, then I apologize for any formal errors there. Then I want to try and draw out what I take to be the implicit or explicit metaphysical commitments of these measures, so what they think they're claiming to do, and whether that's plausible. And then finally, think about how we could take this as a new way of thinking about the metaphysics of causal emergence, so a kind of new scientific metaphysics for causal emergence at the end there. Cool. So for the metaphysical background, I want to ask two questions. So one is, what is causation such that it could emerge? And the other is, what is emergence such that it could be causal? So here are some candidate theories of causation. Regular co-occurrence, so it might just be things which co-occur together in some sense. One causes the other, the first one causes the second, kind of humane theory. You've got counterfactual theories, so for X to cause Y, it might be that Y is in some sense counterfactually dependent on X occurring. It could just be that X increases the probability of Y in some sense, probabilistic theories of causation. It could be that there's some kind of transmission of a quantity or mark from X to Y, process theories. It could be that we learn something about the causal connection between X and Y by manipulating X and seeing what happens to Y. So these come in a variety of flavors, but either agential or interventionist theories are probably the most common. Or it could be maybe a more fundamental account of the powers, capacities, or dispositions which we think causation is. So to cause something could be to have a causal power or a causal capacity, causal disposition. And all of these, I think, are possible candidates for emergence, perhaps. So they could be greater causal power at some emergent level. They could be greater probabilistic influence, and so on. But some, I think, are more plausible than others. We'll see. The powers, capacities, or dispositions, I think, is maybe closest to a kind of intuitive, maybe even folk notion of what causation is. And consequently, what people sometimes want when they're thinking about an account of causal emergence. So to say there is an emergent cause, for at least some people haven't thought about it too much, might mean there's in some sense more causation at the higher level of organization. There's more causal power when you rise to this higher level. Finally, you've got a variety of non-reductive accounts. So these are all reductive accounts which try to explain causation in terms of something else. I'm bracketing the non-reductive accounts for now because I'm not sure it will be easy to make sense of causal emergence on these accounts. If there's just distinct kinds of causal explanations in different kinds of domains, we're not going to get causal emergence. What we might get is something like causal autonomy. So it might be that causal explanations or causes in different domains are autonomous from one another, but we're not going to get one set emerging from some lower level set. I carried out a kind of informal poll of Twitter and what they think causes are, and we got candidate responses for all of these. So people don't agree what causation is. That's the good news for me. You get people giving all of these very confidently. They say this is absolutely what causation is. If I've missed your favorite theory of causation, you can ask me in the Q&A, and we can try and work out how that fits into these approaches to causal emergence. Yeah. So those are some different kinds of cause. As we'll see in a minute, these information-theoretic accounts, perhaps unsurprisingly, if you think about it for a little bit, focus more on probabilistic accounts of causation, or maybe manipulability accounts. So those are going to be the focus here. But it's possible that people might have something else in mind when they think about what causal emergence could be. Okay, what is emergence such that it could be causal? So again, this is really glossing over a bunch of complicated metaphysics, so I apologize if I've missed your favorite approach to what emergence is. On the one hand, we've got strong or ontological. These may or may not be different things, but some kind of strong sense of emergence where you can get genuinely novel higher level causes. So at some higher level of organization, there are new causes, or there's more causal power, or something like this. This is going to depend a little bit on what you think causation is in the first place, but there's at least something new going on. Then we've got weak or epistemic emergence, which is rather than there being anything ontologically new at a higher level, there's just better causal descriptions or explanations, or we can better track them, or something like this. So there's some epistemic advantage for us as investigators of causal systems, but not anything actually new in the system. So this is a kind of strong, weak, or ontological epistemic distinction we might have here. People sometimes distinguish between synchronic and diachronic emergence. So synchronic emergence, as I'm understanding it, is that we've got novel causes in some sense simultaneously with the lower level causes. So at the same time, we have some microphysical causation and then some macrophysical causation which supervenes on that, but is greater than it in some sense. Whereas diachronic emergence would be the emergence of novel kinds of causal processes or levels over time. So these aren't necessarily supervening on microscopic causes, but they're emerging in the sense that there's kinds of causal structures or kinds of causes which weren't previously there in the system. And we can couple these up in different ways. So strong synchronic emergence might mean that at the same time, there are some set of microphysical causes and some stronger set of macrophysical causes. Weak synchronic emergence might just mean that we can better capture the microphysical causal dynamics with some kind of high level description, but there's nothing new in the system. Strong diachronic emergence might mean, okay, that we get some kind of novel causal processes emerging over time, but these might just be low level. So it might just be that we get more causal power microphysically in a system as the system evolves. So you might think that complex systems do this, even if you don't think that they're strongly synchronically emerging. It might mean that you get some kind of causal integration over time in a system. And weak diachronic emergence will just be something much simpler, like that complex causal structures which can be explained better at a higher level of analysis emerge over time. So the evolution of complex organisms might look something like this if you're not a strong emergentist. It might just be that as they get more complex, this forces us to move to a more kind of abstract or coarse-grained level of description. So these are all different kinds of things we might mean when we talk about causal emergence. Okay. So like I said, what I want to look at today is these three information-theoretic measures or theories of causal emergence. And they've come primarily from neuroscience, I would say, but also from complex systems theory and the intersection of these two things to some extent. So Eric Hoel and colleagues have defined a measure of causal emergence, well, a measure of causation, which they call effective information, and I'll briefly talk about this. And they use this then to measure causal emergence. So insofar as you buy their story about effective information as a measure of causation, if there's more effective information at the coarse-grained kind of level of a system, then there's going to be more causation there. The measure of effective information, as we'll see, is quite Pearl-inspired, so inspired by Pearl's do calculus. So in that sense, it's either a probabilistic or an interventionist account of causation. So essentially what it's doing is intervening on a system and seeing what that intervention tells you about future states of the system as a measure of causal power. And I'll discuss later whether it's strong or weak, but it's a form of synchronic emergence. So it's saying there are systems where if you, at one at the same time, consider them in a coarse-grained fashion, that there's more causation at the coarse grain in some sense. And I'll say more about that in a minute. Jessica Flack at the Santa Fe Institute has got an account of what she calls collective computation and strong or weak downward causation. And this is diachronic. This is over time, as we'll see. So this is how systems, as they evolve over time, might exert a kind of downward influence in some way, which she thinks is downward causation. And again, this is a kind of probabilistic or predictive flavor. Finally, Fernando Rosas and a bunch of colleagues, including Anil Steph, who some of you might know, has looked at decoupling and downward causation in multivariate data. So this is probabilistic again, but importantly in a Granger sense. So he's talking about Granger causes rather than Pearl causes, and we'll talk about that as well. And I think he argues for a kind of weak synchronic emergence. Okay. So I'm going to go through each account in more detail now, and then consider their metaphysical commitments. Okay. So Eric Hoel defines, well, he takes from Tannonian spawns a measure of causal power in terms of effective information. So this is meant to be a quantity capturing all the causal interactions that can occur between two parts of a system. That's how they define it. And as I said before, this uses Pearl's do calculus. So the idea is you essentially intervene kind of randomly on a system, and the degree to which that random intervention tells you about future state of a system tells you how causal the connections are in those systems. And I'll give an illustration of that in a moment. And then what Hoel does is he shows how coarse graining a model can increase this measure. So by grouping together seemingly indeterminate or kind of weakly causal microstates into a single more determinate or more causal macrostate, you gain causal power in the system. And by using this measure, he concludes that there can be more causation at the macro level because the coarse grained model contains greater effective information. That's a kind of rough non-mathematical argument there. So to give a minute. Yeah, here we go. And I think you should be able to point with this laser pointer. So they illustrate this using these Markov chains or these transition probability matrices down here. And the idea is these are all 4-state systems. So each system's just got these 4 states from 0, 0 to 1, 1. But system 1 here, it transitions determinately from each state. So if you intervene to set it into state 0, 1, it will determinately transition to state 0, 0, and so on. So this has got maximal effective information, which means it's a kind of maximally causal system. There's the most causation there can be in this system in some sense. Whereas this system here, between some of the states, it transitions with a 1/3 probability. So if you set it into 0, 0, it's got a 1/3 chance of either staying in 0, 0 or transitioning to itself, moving to 1, 0 or moving to 0, 1. And then a little bit of determinacy here. So once it settles into 1, 0, it will determinately transition to 1, 1 and then stay there, or flip back maybe. And then you get into this. So this is just a kind of a different way of presenting that. And this has got less effective information. So according to their measure, there's less causation in this system. And then here you've got the kind of minimally causal system. So this system essentially just transitions randomly. It's got 4 states with a quarter chance of transitioning to each other at any time. So that's just got 0 EI. It is causal, but it's as kind of minimally causal as it could be according to their measure. Okay. And then you can see here what happens when you've got a system that we could coarse grain in a way that increases effective information. So this is an 8-state system. 7 of the 8 states just transition with a probability 1/7 to each other. So they just essentially randomly transition into each other. This 8th state always transitions to itself. It just stays in the same state. And this is quite a weakly causal system. It's got only 0.18 EI when you measure it, or sorry, 0.55 bits. And the idea here is we can coarse grain it. So if we're not interested in the particular details of which of these states it's in, these first 7 states, we can group them into a single state. Just call them, give them a new name. And then at this coarse grained level, this state will also be determinate. It will just determinately transition to itself. And this gains you 0.45 bits. So we're up to EI1 now. And now the system is kind of as determinately causal as it could be. So the claim is that by coarse graining the system, we've raised the effective information, demonstrating causal emergence. This is just another kind of system. So it doesn't need to be that the states are all the same. We could have these 7 very messy states, which have got all kinds of different probabilities, but they only transition to each other. So we can again coarse grain them into the same model. We can just use the same model here. If we don't care about the particular identities of these 7 states, we can just group them all together, and then we get this 1-to-1, 1-to-1. So again, by coarse graining the system, we can raise the probability. So this is a causally emergent system where there's more causation at the coarse grained level. Okay. Cool. So you probably got lots of questions about that, but we'll leave it for now and move on to Flack's example, Flack's description of collective computation. This is quite different. So she's considering cases where adaptive systems produce and use coarse-grained models of their own microstates in order to kind of regulate those microstates. So these could be social, biological, or artificial systems, all kinds of systems, just the kinds of things which complexity scientists at the Santa Fe Institute like to study. And she describes this as emergent downward causation when an aggregate macro model, so this kind of coarse-grained model, causes novel regularities in the microstates. And we could think of this as a kind of self-regulation or tuning. So by using this coarse-grained description of its own microstates, the system becomes more kind of consistent. And she describes this as downward causation. She distinguishes here between apparent and effective, which she calls weak and strong at another point. But the only difference is really one of strength or degree. So the term apparent downward causation is when the tuning is partial and imprecise, and the term effective downward causation is when it's strongly predictive, robust to small perturbations, and increases mutual information between micro and macro. I'll go through these examples. This is just a model. So we've got the downward causation here, where the individual microstates are using the coarse-grained model to kind of regulate the behavior. She gives 3 examples here. So macaques producing coarse-grained model of social status in their groups and using this to govern their behavior. I won't worry about the full quotes here. Endogenous coarse-graining in molecular systems. So this is an approach used by scientists studying molecular systems where it's very complicated and you're not sure what kinds of types of molecules you have. And what they're doing here is they're identifying not just all the different kinds of patterns, but the patterns crucially here that the system recognizes and uses. So they're using the kind of functional relevance of the different kinds of patterns here as a kind of coarse grain, which helps them study the system. And she thinks it's a kind of downward causation. And artificial neural networks as well, she thinks of as doing something like this. This is, as we'll see, a kind of diachronic causal emergence instead of synchronic. Finally, Rosas et al.'s multivariate analysis. So I'll just, this quote here I think is the important bit. They're looking at cases though where a description of the whole better predicts the future states of either the whole or some part. So this is causal decoupling or downward causation. And causal emergence for them takes place when a supervenient feature has irreducible causal power, when it exerts causal influence that is not mediated by any parts of the system. So this sounds like a kind of strong causal emergence. Yeah, and then they talk more about that in informational terms in a minute, which I'll emphasize later. Just show what they're doing here. This diagram's better, I think. So the VT here is the coarse grain of these microstates, which just evolved to some other microstates. But when the coarse grain gives you a better prediction of either the next coarse grain or some of the next microstates, they describe this as a kind of downward causation. And I'll come back to this, but importantly here, by causation, they have in mind Granger causation, which is acknowledged by them and others in the field as a much weaker sense of causation than most people normally mean. So all it means is that we can better predict VT bar given VT, basically, than just given these states. So given that this gives us more predictive power about VT bar, we can say that VT is causally emergent over these microstates. Okay, I won't spend too long on these. Conway's game of life, some of you might be familiar with, exhibits some of these features. So by thinking about the kind of macro state rather than each individual cell, we can better predict the next state of the system. These Boyd models, which are birdoids, kind of artificial bird simulations in their flocking behavior in a kind of middle state, kind of Goldilocks zone, you get something like this going on, rather than completely determinate or completely random, or quite random. And you get this in when you're analyzing neural data. So by looking at the behavior, the kind of physical behavior of the movement of the wrist, you get a better prediction of future states than just looking at all the individual measures from a neuroimaging. Okay, I won't spend too long on that. So yeah, these are the 3 accounts again here, which I had before. Oops. Both Hoels and Rosas, so they're both probabilistic in different senses, but they're both synchronic as well. So it's just saying by looking in the here and now at the coarse grain description of some microstates, you can better predict the next states of the system, basically. Flack's is a bit different. She's saying that a kind of informational coarse graining of the system on itself over time seems to exert some influence on the system. And she calls that downward causation. Okay, I realize I raced through this slightly quickly, but I realize I'm running out of time here. Okay, so their metaphysical commitments. So sometimes when Hoel's talking about this, it sounds like he's talking about something epistemic. So a macro scale description of a system, a map, can be more informative than a fully detailed micro scale description. That's kind of seems like a weaker epistemic form of emergence. But then he sometimes talks about something more ontological. So sometimes he says the macro beats the micro in terms of efficacy, informativeness, or power of its causal relationships. That sounds like something quite different to just saying that we learn more about the causal relationships. And I think this epistemic description sounds much more plausible, but it's also much less exciting. And it's important here to know that he's coming from a context of an information-theoretic account of consciousness, the integrated information theory. And if what you're interested in is how consciousness can be understood in causal terms and have some power over and above its physical microstates, so it's not just epiphenomenal, then you're going to want something much more like this second thing, rather than just the first thing. You're going to want something much more like extra power rather than just more informative. So I think Hoel's unclear really about whether he has the first or second of these two things in mind. I'll skip this, but there's a good discussion between Scott Aronson and Eric Hoel if you're interested. So Flack gives maybe a more operational or instrumental definition of emergence. So she says we can reconcile these kind of older philosophical conflicts by being operational and examining how adaptive systems identify regularities and use them to guide behavior. She makes this weak strong distinction, but I had this quote before. It's just it's really not. It's just between two different strengths. It's not between anything like ontic and epistemic. She finally says, I will not discuss in this paper when the operational concept of downward causation I'm proposing conforms to strict definitions of causality. So this is, I think, where we get something more interesting, that she doesn't really care about what philosophers and metaphysicians have said about causality. She's interested in finding new ways to describe what she sees to be causal relationships in systems. That's just, don't worry about these. Yeah, that's fine. Rosas as well, so sets out to address what he calls, or they call, the paradoxical properties of strong emergence. But I think with a seemingly epistemic flavor. So weak emergence are systems which have irreducible causal power in practice, but not in principle. So it's just that in practice, we need to think about causation at higher levels because it's easier for us to understand or something. But not that in principle we can't reduce these features. And also here, they're understanding causality in this Granger sense, like I said before. So it's really just predictability. And this seems like something quite distinct from what strong emergentists want to causally emerge from a system. Yeah, it doesn't matter. So here we go. I think this quote is quite telling. Our theory of causal emergence is about predictive power, not explicability, and therefore is not related to views on strong emergence such as Chalmers's. Nevertheless, our framework embraces aspects that are commonly associated with strong emergence, such as downward causation, and renders them quantifiable. Our framework also does not satisfy conventional definitions of weak emergence. Hence, our theory can be seen as an attempt at reconciling these approaches, showing how strong a weak framework can be. So they're very aware that their approach is primarily epistemic, but they also want it to be something stronger than this. So what could that be, I suppose? Okay, this is just summarize the three views here, or what I take to be their metaphysics. And in each case, it strikes me that these don't really fit neatly into our kind of typical distinctions between strong and weak emergence, or epistemic and ontological emergence. So just in the final 5 minutes or so, I want to consider 3 different options to what I see as a new scientific metaphysics. So if instead of trying to force these views into our preconceived notions of what causation is or what emergence is, could we use them to develop a new metaphysical approach? So firstly, we could have a kind of deflationary sense of causal emergence. So if causality just is something epistemic, so either in the Pearl or Granger sense, if it just gives us more predictive power about a system, then it might make sense to talk of it as emerging as we coarse-grained system. So if that's all causation is, then maybe there is actually strong causal emergence here. And this wouldn't be the emergence of novel causal powers, rather just the emergence of stronger predictability, but with the important caveat that that's all causation is. So if you're skeptical of these kind of more metaphysical accounts of causal powers, then something like Pearl or Granger causality might strongly emerge in a system. And yeah, whether it's strong or ontological would depend on all these other questions about whether you think there's anything stronger it could be. If Pearl or Granger causality is all there is, then maybe there's strong emergence in this information theoretic sense. So this isn't a different approach, but a kind of another way of thinking about it is we could think of these just as methods to quantify novel emergent structures or patterns. So not necessarily anything directly to do with causation as such. So even if you think causation is stronger than mere predictability, these measures could identify the kinds of systems where autonomous or sui generis causal analysis is appropriate. So for instance, systems which have more of Hoel's effective information, even if you don't think there's strong causal emergence, it might be that when you have a system of that kind, it's appropriate to coarse-grain it. And these new causal analyses haven't emerged, but they're most appropriately understood without reference to lower level causes. So this could actually fit with more of a non-reductive approach to causation, I think. This could tell you when a different pattern or style of causal explanation is most appropriate. And I think this could fit well with what people like Anderson have called pattern ontologies, developing the kind of anti-metaphysics of Dennett in real patterns and Ladyman and Ross in Everything Must Go. So if you think all there is in some sense are just these patterns and causation should be fitted into that framework, then it could be that different kinds of pattern analyses are more appropriate at different levels, and these information theoretic measures tell you something about that. Finally, and most radically, if you adopted a kind of information theoretic or computational ontology, then you might get a very different kind of causal emergence. So if the basic structure of the universe is informational in some sense, then this epistemic ontological distinction begins to look a bit stranger, maybe not right. And some interpretations of a Bayesian or Pearl approach to causality, I think, suggest something like this. And more generally, the idea of a kind of information or computational ontology is taken seriously by a minority of physicists, somewhat eccentric physicists, perhaps. It's still not clear to me if this would get us genuinely strong causal emergence. So does coarse graining in this way change? So if you think the basic structure of a universe is the probabilities, you know, that the whole universe is just a Bayesian causal graph at its most fundamental level, does coarse graining a system in the way that Hoel describes actually raise the objective probabilities in that graph, or just our subjective assessment of them? If it's just changing, you know, our graphical model of the universe, that seems like a kind of epistemic emergence. If somehow coarse graining a system, you know, the very act of coarse graining a system, or the fact that a system can be coarse grained, changes the objective probabilities, then maybe we get something more like strong causal emergence. I throw this final idea in just as kind of a most radical example. I'm not necessarily wanting to endorse it. Yeah, that's fine. Okay, so just anecdotally, the reason I got interested in this is when people get excited about causal emergence, I think they're excited about the possibility of emergent mental causes a lot of the time. So that mental states might have some power over and above their physical substrate. This is certainly what Eric Hoel's excited about, and a lot of people got excited about, well, a lot of neuroscientists, I think, got excited about his ideas, or psychologists anyway. He wanted some way to have causal mental states over and above physical states. But I don't think these new formal measures are likely to get us anything like that in a kind of more traditional mental causation sense. So this deflationary approach gets us better predictability, but it's not like there's more mental causation at the coarse-grained level. There's just maybe a better understanding of it. And pattern emergence might get us explanatory autonomy. So it might explain why we should think of coarse-grained descriptions, you know, so why psychology is autonomous from neuroscience or something, in an information theoretic sense. But I don't think it's going to get you more mental causes or kind of novel mental causes. The information theoretic ontology I mentioned last might get us something more exciting, but it's quite strange. I think if in order to get strong information theoretic causal emergence, you need to buy into the basic structure of the universe being a Bayesian graph or something like this. That could be fine, but you've got stranger metaphysical commitments already at that point. So what's important, to get back to the theme of a conference, what's important from a kind of methodology perspective, I think, is that we understand, on the one hand, what people are excited about, so what people want from an account of causal emergence, and then on the other hand, whether the formal measures can achieve this. So what I worry about is someone like Eric Hoel selling this idea and people going, whoa, strong causal emergence, that's great. Consciousness is autonomous from the physical body. And I think they read in what they want to into this quite technical, quite formal measure. So I think there's maybe a useful role here for philosophers in trying to bridge between these things. So work out, on the one hand, what people want, and on the other hand, whether they're getting it. Maybe a kind of trading standards for scientific metaphysics or something. Okay, so this deflationary plus pattern emergence, so the first two ideas for a new metaphysics here, could get us an account of how to determine which grain of a system is most amenable to intervention or analysis. And I think that's a pretty cool thing. So Hoel can tell us how to intervene to cause the states that we care about most, so those which we group together. Flack can tell us how a system models itself for the purposes of regulation, and Rosas can tell us how to build a coarse-grained model that preserves, in some sense, the causal dynamics of a system. And that's useful for all kinds of scientific reasons. But whether it's strongly or weakly causal would depend on what we mean by cause. And we could get bogged down in very boring discussions about what causation is. Sorry, people who do that. But also, you know, these scientists might not be interested in doing that. They might just want to say, this is what I mean by causation, and there's now more of it in this system. And that's something which they're maybe open to do, but it's important that we don't confuse that with something else. I don't think it will get us a measure of strong causal emergence in a kind of traditional metaphysical sense, but perhaps I don't quite know what that is yet. And it's not necessarily obvious that we should care about that. If they've shown something else, then maybe we don't need the traditional strong causal emergence. Okay, so yeah, there's some conclusions, and I'll stop there and we can take some questions. There's a nice quote from Anderson, actually, I just wanted to highlight here. So she suggests, in thinking about pattern causation, that we might be getting, well, so she's actually appealing here for a formal account of pattern causation, which I think some of these approaches could give us. She suggests that these kinds of formal analyses could mark the beginning of the end of causation as a specifically philosophical rather than scientific discipline. And I think that's quite an interesting idea. Thank you.